Hello my dear students, 10B and 10C. Me Mr.Dlear, your math teacher. In section 1, we talked about inverse variation. We learned what the meaning of inverse variation, and we learned how to finding the constant k and what's the relation between x and y. Today we have another section 2. Section 2 about rational function. In this section we will learn how to find the domain of the function, very important domain, and concept 2, how you can find the vertical asymptote, very important for grade 12, and horizontal asymptote, how you can find horizontal asymptote. Then we have 3 concepts in this section: domain, vertical asymptote, and horizontal asymptote. Let me start. The page of this section is 188, 189, and 190. First, we have to know what means a rational function. Which one is a rational function? Rational function is that function is formed by what? By polynomial, should be polynomial over polynomial. We have fraction, the numerator, as you know, this is fraction, and this is numerator, and this is denominator. Numerator polynomial and denominator also polynomial. You know what means polynomial? We studied that in this chapter maybe 3 in term 1. But let me remember what means polynomial. Polynomial is this one, f of x, for example, x plus 1 over x squared plus 2x plus 1. This is polynomial over polynomial. Then we have rational function. For example, it's not polynomial. Polynomial should be variable or number separated by plus or minus. Example for not polynomial, if you have radical x, absolute x, x to power fraction, x to power 1 over 3, this is not polynomial. Another example for not polynomial, this is all not polynomials. 2 to power x is not polynomial. X to power minus 2, this is not polynomial. All of them, if you see it in expression, this is not polynomial. If you have radical, absolute sign, x to power, the exponent as fraction, exponential function, x as power, or negative power, all of them is not polynomial. Polynomial over polynomial, then you have rational function. Another example for rational function of x is equal to 2 over x plus 1. This is polynomial, and this is also polynomial. Of x is equal to x to power 5 minus 3x plus 2 to power 4, x to power 3. Polynomial over polynomial. Polynomial over polynomial is a rational function. Of x is equal to x to power 5 minus 3x blah 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 over x squared minus 4. This is all of them is rational function. Okay. Now you know what means rational function. Polynomial over polynomial. This one is not rational function. Example for not of x is equal to 2x plus radical x over 2 x squared plus 1. This is polynomial? No. Why is not polynomial? Not a rational function, because this is not polynomial. Look, radical x is not polynomial. This is polynomial, but this is not polynomial altogether. Another example, 3 to power x plus 2 over x over x plus 1. Is this a rational function? No. The problem is with 3 to power x. Look, x as power. This one is not a rational function. Last example, not a rational function. This one, it's not a rational function. You have absolute. Absolute is not a rational function. Okay, next. Now you know what means rational function, how you can find the domain. Domain also is very important. Domain of function. Okay. What means domain? Domain is the possible value of x, what we can put for x. Example, if you have f of x is equal to x plus 2, x minus 1, find the domain. What we can put for x? We can put for x any number except 1. Why? The domain domain is possible value of x. The domain is all real number except 1. Why? Question mark. Okay, replace. Let me find f of 1 is equal to what? F of 1. Replace x with 1. 1 plus 2 over x1 minus 1 is equal to what? 1 plus 2, 3. 3 over 0. Number over 0 in math and defined. Impossible divide by 0 in math. Then you can say the domain of this function is all real number or R يعني all real number. You can put any number except 1. Okay, this is the domain of a rational function. Another example. Find the domain of each rational function. One. F of x equal to 2x squared over x plus 3. 2. F of x is equal to x plus 1 over 2x minus 6. 3 f of x is equal to 4. F of x is equal to x minus 4. Find the domain of each function. Okay. Let me start first one. Answer first. So the domain of f of x, the first one, look to denominator, just denominator, only denominator. This one, x plus 3 equal to 0 means x is equal to minus 3. The domain, this means domain, domain, or real number except negative 3. We can put for x any number except minus 3. 2. What's the answer? Just look to denominator. Don't care about numerator. Just denominator for domain. Domain, look to denominator only for domain. Denominator. Down. Equalize to 0. 2x minus 6 is equal to 0. 2x is equal to, we move 6 to another side with different sign, will be 6. because negative will be 6. Divide by 2, divide by 2, x become 3. Then what's the domain? All real number except 3. Okay, this is the domain of first one, second one. What about third one and 4? Number 3. What's the domain? X square. Number 3. We care about denominator only. Just look to denominator. Only denominator equalize to 0 to find the domain. X square plus 1 is equal to 1. Ignore this one. Solve this one, sorry. We move minus 1 to another side with different sign, become negative 1. Now square root and square root. As you know, x squared with radical y by x is equal to square root minus 1 is equal to what? If you have calculator at home, write this type. Radical minus 1 is equal to what? The calculator will give you undefined math error. Undefined because square root and the square root should be positive. It's not negative. If you have negative under square root, then it's undefined. And this is never equal to 0. You write x squared plus 1. This is never equal to 0. Then what's the domain? If denominator is never equal to 0, this is never equal to 0. What does mean the domain? Means we can put for x any number, all real number. And all real number, sometimes we can write it like, sorry, from minus infinity to positive infinity. This is same this one. All real number. What's the domain of this function? What we can put for x? We can put for x any number. It's always defined, okay? 4. F of x is equal to 3x over x squared minus 4. Find the domain. The domain is only denominator we take, equalize to 0. Solve this one. You can solve this one by difference between two squares or by square root, as you like. If by difference by factorize x squared, x minus 2, x plus 2 equal to 0. By difference between two squares, we solve it. From this one, x is equal to 2. From this one, x is equal to negative 2. Then the domain, what we can put for x, the domain is all real number except negative 2 and 2 negative 2 and 2. If we replace x with 2 square 2 square 2 2 to power 2 4 minus 4 0 undefined. If we replace minus 2 square is 4 minus 4 0, then the domain of this function is all real number except minus 2 and 2. That's first concept for today, and tomorrow I will teach you how you can find the vertical asymptote and horizontal asymptote. Thank you. Bye bye.